I want to say welcome to you all. Good morning, good afternoon, or good evening, depending on where you're joining us. I will do a few housekeeping items. While I'm doing that, you'll notice it towards the top of the screen, there's a resource box. If you would like to go ahead and download the PDF version of my slide deck, it's now available there for you. And also there's a PDF that is actually a promotional flyer for our EPDC series on Artemis Learning Pathways. You may be aware that we are in the midst of a wet dress rehearsal for a launch of Artemis 1. And in preparation for that, the NASA Office of STEM Engagement is holding a series of both educator professional development webinars and also student STEM engagement events, all virtual. And so if you'd like, you can go ahead and download that flyer. It'll give you more details. And I believe each of the dates is hyperlinked. So if you see a date and a topic that you'd like to know more about, you can actually register for the event from the flyer. I'll leave that up for a couple of minutes, but I'm going to go ahead and do my housekeeping items while you're doing that. Tonight's series is part of our month-long focus on the Explore Earth communication theme here at NASA, and I'm specifically going to take a look at sea level rise, a number of new tools that NASA has made available based on some new satellites that we have that are allowing us to continually monitor Earth's climate through what's happening to the planet's oceans. So that's what you're here for this evening, hopefully. And you may see a furry assistant walk by the camera every once in a while. I have two feline education specialists who are patrolling or prowling, as the case may be this evening. I've had my demonstration materials already checked out and verified by both of the fuzzy assistants, so we're all good to go. In front of you is the roadmap for where I'm going to take you this evening. I'm going to do an activity demonstration. I'm going to talk a little bit about Earth Day since it is April and we're about 10 days out, actually a little bit less than 10 days out from Earth Day 2022. Talk a little bit about current events, which provide sort of the rationale for me covering this topic. And then I'll talk about those new ocean monitoring tools and Earth observing satellites, some of which you can incorporate into your classroom through some of the activities and instructional resources that I'm going to share with you along the way. Many of you have discovered the chat box. That's a way for you to communicate with me during the program. If you have questions, please feel free to drop them in the chat box and I will try to catch them as we go along. If I miss your question, I will stick around for a couple minutes after the program and circle back around and answer any questions I might miss. So please do not be offended if I miss up. It is April 22nd, I believe. I think I'm going to have, yep. Thanks, Adrian. I was going to say I was going to have somebody back me up there. So April 22nd. And so students, particularly if you have questions, feel free to drop those in the chat box. As I said, if I miss it during the program, I will circle back around and make sure that I try to answer it before you sign off for the evening. This is a professional development opportunity for educators primarily, although we do welcome students and informal educators and parents. But this is a professional development opportunity for United States K-12 teachers, and as such, I am taking attendance that is then fed into our system, and you'll get an email within the next 24 hours that will contain a post-event quality survey. You will want to fill this out if you would like to get a certificate of attendance. You must fill out the survey in order to get the certificate that you attended this evening. The survey is about 10 minutes, 10 questions, 5 minutes long. It's multiple choice. It basically lets us know what you did and did not like about the program. You must fill out the survey in order to get the follow-up email, which for me goes out about a week later. That will contain the link to the certificate of attendance. So make sure that you fill out the survey. For those students who may be with us this evening or informal educators who may not necessarily have a formal classroom all the time, just go ahead and fill out the survey the best that you can. That way then you're in the queue to receive the certificate. And I always make my slide slide decks available. I obviously have provided a PDF version this evening, but I usually put together a resource email that gives you a link to download the actual PowerPoint from Google Drive. I mentioned at the very beginning I am recording this session, so the resource email contains that. It contains a whole set of other goodies that are related to this evening's topic. So if you're interested in getting the resource email, please feel free to drop your email address in the chat box. You can either do it in the public section, or you can hover over my name and send me a private chat if you're not comfortable with putting your email address where everybody can see it. My emails usually, and I do stress, usually go out about a week to 2 weeks after the program. It takes some time for the recording to buffer and for me to compile all the goodies that I tend to throw into a resource email. So for the resource email, just be aware that it does take a bit of time. It was a little bit longer than that recently because we had a bunch of stuff going on at NASA. Izar is asking about the certificate. Izar, I'm going to give you my email address at the end. If you could just send me a short email indicating that you would need the certificate sooner, then I can take care of that. But yeah, each specialist does it a little bit differently. So some specialists have a much shorter time scale, but I know that there's things that happen. So I try to give folks extra time just in case life happens, so they make sure that they get their certificate. So for those of you who may not know me, my name is Dr. Ann Weiss. I am Education Specialist at NASA Langley Research Center in Hampton, Virginia, along the East Coast of the United States. And so tonight's topic is of a special importance to us here on the coast. We have quite a bit of what we refer to as nuisance flooding or tidal flooding that happens during high tides. So this is something that's especially important to us at Langley, which does actually specialize in Earth observing satellite data and instruments that are in space to basically track what is happening with the Earth. So I'll talk a little bit more about that in a few slides. But my background is as a biologist, as a research scientist, and so that's how I started out. About partway through my master's degree, I discovered I loved teaching, and so that was my pivot point. My first couple of assignments as a teacher, K-12 in rural Virginia here, was as an earth science, physical science teacher. You may be wondering, how does a biologist end up teaching earth science? I actually was a physics / space science / earth science major when I first started in college, and then changed my major to biology. So that's how I ended up teaching earth science. So that's another reason for my interest in this topic this evening. So I've done a little bit of research, but most of my career has been in education, some of it in the classroom, and a good portion of it now has been with NASA education. So I'm particularly excited to be able to share this topic with you because I'm able to kind of tie together the more technical earth science research piece of it with the education and the activities portion of it. But I do want to make sure that I'm quite clear up front that this is not a technical talk. I am not going to go into great technical detail about the data sets, or that I'll provide links where you can get more information. What I'm simply going to do is provide an overview so that teachers are able to use that as an introduction to the activities that they might want to incorporate in their classroom and in their curriculum. So with that, let me just quick check back and just make sure that I didn't miss any questions. So for those of you who are kind of helping me out in the chat box and answering questions, thank you very, very much. But yes, I will make sure that you have my email address if you don't already have it, so that you can give me a notification that you are in need of the survey quicker, or excuse me, the certificate sooner as opposed to later. I will bring back the resource email later at the end of the program, but what I want to do is I want to start the activity demonstration, because what I need to do is I need to let it sit for a little bit, and I'm going to go ahead and try to get my camera box in front of my slide box here, if I can get it to cooperate, which of course it does not want to cooperate. So I'm going to go ahead and minimize my slide. So I'm going to start with an activity comes from NASA JPL Education. It's entitled What's Causing Sea Level Rise? And so this is a demonstration, rather straightforward. I'm just going to go ahead and minimize that. I will bring it back. I'm just simply having a little bit of technical difficulty trying to get my box to cooperate here. So almost ready. Okay. All right, so in order to do this activity, I've gone ahead and done a little bit of pre-setup work before getting started here, so I'm good to go. All right. So what you want to do is you want to get a couple of containers. Could be glass Pyrex. I've got a couple of Glad plastic sort of sandwich containers here. And what you want to do is, in addition to the lids and the containers, you'll want to get some Play-Doh or some sort of clay that will allow you to create land masses. And I'll rotate this around a little bit here so you can see it. I've already actually poured the water in. I'll bring it a little bit closer to the camera so you can kind of see. So on what is my right, but might be on your left, is what looks like sort of a fuzzy purple mass. That is my piece of Play-Doh. It's going to represent my land mass. And then if I shake this a little bit, you'll probably be able to see I have a little bit of water in here. So I've created two canisters, one with the purple piece of Play-Doh, and then the second one here I have is actually, let me raise it up here, is orange. So you want two identical setups here, because one is going to represent the model of, say, a glacier or land ice, and the other is going to represent icebergs or sea ice. Okay, so you want to try and make sure that everything is the same except for where you're going to place your ice cubes, which are going to be our stand-ins for either a glacier or an iceberg. So one of the other things that I've done is I'm going to go ahead and I'm going to rotate this around, is I've made a mark with a piece of blue painter's tape on the side here to indicate where the water is initially when I start this demonstration. And I'm going to go ahead and I'm going to get my ruler here, and I'm going to take a quick measurement. As I said, it needs to be the same for both of the canisters. And let's see, it's got one, we'll say it's about 1.3 centimeters is the depth of the water, was what we're going to start out with. So I'm going to make a slight notation. I'm going to move my box here, and I'm going to make a notation that our starting depth, water depth, is 1.3 centimeters. So starting water depth, and remember this is for both containers, equals 1.3 centimeters. Okay, all right, so that's what we're going to go ahead and start with. I'll bring this back, and it's actually probably really important that I also designate this. We're going to say that purple will represent my land ice, and the orange will represent the sea ice. Okay. So this demonstration that I'm going to set up right now at the beginning and then come back to at the very end is a simple demonstration that you can do with your students, whether that's your formal classroom or informal classroom, etc. And what you want to do is you want to ask them, just like I'm going to ask you right now, which do you think is going to have the higher depth or deeper depth of water at the end? Do you think it's going to be the land ice canister, or is it going to be the sea ice canister? So which one do you think the water level is going to be higher at the end? You can just drop that in the chat box. Well, like quick setup. So go ahead, drop that in the chat box. Getting ideas to okay. I got a vote for sea ice. Magdalena is saying desert, so we'll call that a land vote. Okay, Paul's going to go with sea ice. Okay, Kiyomi's going to go with sea ice. Joe's going to go with sea ice. Anybody else want to weigh in before we move into the slides? Okay, I'm not seeing anybody else type, but what I've done, and in the 20 or so minutes or so that it's taken between the time that I got these out of the fridge and the actual time that I'm able to set them up, the ice cubes have melted just a little bit, but the ice cubes are all about the same size. I made sure to use my ice maker in my refrigerator to make sure that the ice cubes were all about the same size, and I had a handful, so I brought a total of 7, 3 for each container. So once again, I want to make sure that all of my variables are controlled except the one that I'm testing. So this is always good for testing basic nature of science in our curriculum. And then I had the 7th one so that I could actually show you. And Tejas is also going to vote and weigh in with the sea ice. Okay, so that's what we're going to do. I've set it up and I've got to let this sit now for the rest of the webinar. And I'll come back to this at the end. I'm just going to move this off slightly to the side and let it go. And also very important, as I've noticed a couple times since I've done this, this is why I have the lids, because as some of you have noted, I have furry cat assistants, and so I have at least one who loves to quality control check my water. Of course, this is probably a problem that you would not have in a usual classroom, but since we're still in telework status, I have that little issue that I have to address. So the lids are on. I've put in the information in the chat box, so we'll let that sit for the next 40 minutes or so, and we'll come back and measure it and see which one wins, the sea ice or the land ice. Okay, so let me bring back my slides, and when you get the slide deck, whether it's the PDF that you've downloaded before or after tonight, or the PowerPoint that you'll get from Google Drive a little bit later, it'll have all of the links. So everything that you're seeing on the screen, you will actually get at some point, and I'll include the links for the videos that I showed at the beginning before we started. So, all right. So when you get the PowerPoint or the PDF, you'll have the link for this particular activity at JPL. Okay, so we go ahead and had the question, or poll question, which is it, and we'll come back and see which one wins at the end. Okay. All right, so what I'll do is quick talk just a little bit about Earth Day, since we are talking about Earth system science and Earth science. And I want to share with you a interesting quote that I heard not this past year at SEEK, but the year before, 2021, when we were most definitely still in COVID pandemic and everything was virtual. And Dr. Lindgren, who is a NASA astronaut, he was up on Expedition 4445, and I believe that he is either just about to go up again, or he's up right now. I'm not really sure when exactly he's due to go up, but he is due to go up again at some point. He was one of the keynote speakers for SEEK 2021, and at one point he discussed maintenance of the space station, and I was so taken with the quote that I've reproduced it here for you. And what he was doing, and this is what happens to a lot of astronauts, is after they go up and they see our blue planet from 250 miles up, they experience a paradigm shift. I know Chris Hadfield of the Canadian Space Agency has talked about this. A number of other international astronauts have talked about this, and certainly a lot of NASA astronauts, almost every single one that's been up, mentions this to some extent, that they experience this paradigm shift, that the fragility of Earth against the blackness of space just really hits home to them, how we need to take care of our planet, because it is, as was mentioned in the video right before the beginning, it is the only one that we have. And so to think of the planet Earth like a space station, and while we may not necessarily spend 30% of our time doing housekeeping chores or things to help maintain our planet like the astronauts do from the International Space Station, it's kind of important to think about how might we maintain and take care of a planet, which, as Dr. Lindgren pointed out, is really the only space station planet we have at this point. And next crew. Okay, great. Thank you, Adrian. I knew it was coming up soon or was occurring, but I couldn't quite remember exactly. And talking to the astronauts and also talking to those folks who are now having the privilege of riding on Virgin Galactic or Blue Origin on these suborbital flights, they're starting to experience the same thing that the astronauts do. So I believe William Shatner and also Richard Branson both came back and were just absolutely just flabbergasted at what they had seen and the beauty of what they had seen. And they were experiencing to some degree exactly what the astronauts experienced. And so I use that to start off to really hit home that for us here at NASA, every day is Earth Day. One of our charges as an agency is to take the vital signs of our planet, and we do that in a number of different ways and have done that almost from the very beginning of our inception in the late 50s as NASA and the first launches of the satellite. So just a little brief history about Earth Day. This year we're going to have the 52nd Earth Day. This was established in 1970. It was in response to an oil spill that had occurred off the coast of California, and a congressional delegation, which sometimes happens when there's a natural disaster or man-made disaster. It was in this case, a congressional delegation was sent to survey the damage, and there was a combination of senators and congressmen, and one of the senators, who happened to be from Wisconsin, which is part of where my family is and includes a sister who's an organic farmer, Gaylord Nelson basically decided that something needed to be done. And so this was done in collaboration with the United Nations and through a series of initiatives through the United Nations, and then a resolution that was passed in Congress. This brought into existence Earth Day, and it has now grown to the point where almost 200 countries around the world have activities, in some cases not necessarily just isolated to a day. In some cases it's the whole month, and so it's now sometimes no longer just Earth Day, it's Earth Month. And so that is how we kind of take a look at this, and so we are very excited each year when we get a chance to celebrate Earth Day. So what I'm going to do is I'm going to play for you a clip. This is going to talk to you a little bit about an overview of what NASA does in terms of keeping track of our home planet. So give me a second, and I will drop the link for this in the chat box after, because unlike usual, I have to actually share my screen in order to do this. So give me a second. Make sure full screen for attendees. Okay, share, and hopefully this will play. All right, that didn't work. Hold on a second. Hold on. I know that it did not play because I've got it. Okay, we'll try that again. Just share your screen. I think I know what happened. Hold on a second. There we go. This should work now.
The third rock, the blue marble, Earth, home.
Nope, that didn't work either. I don't think you can hear it.
Everything we know, everything we do, every memory we make, it's here on this pale blue dot. It's just one rocky planet.
All right. Let me troubleshoot this again. Volume is soft. Okay, hold on. Yeah, because it's actually not coming through the computer, so hold on. I'm going to try one more time, and if that doesn't work, then I'm just going to give you the link and go from there. Okay, let's try this one more time. All right, it's not going to work for me. Okay. All right, well, we'll go to Plan B. Okay, so I apologize. Unfortunately, I'm not really sure why the screen share is not taking the audio with it as well, but I'll put the link in the chat box. Yep, I'm putting it in the chat box right now. And I will include this link in the resource email. Make sure that's the right one. Yep. All right, I just dropped that in the chat box, so my apologies. I'm not really sure why. And what I usually do did not work for this video. That's why I had to do it a little bit differently. And I'm not really sure why it would not load the way that I normally do. And I'm not sure why it's not playing the video. So I'll just go ahead and put that link in the chat box, and you can watch that as we're going along here, or if you want to save it for a little bit later, we can do that. So the video will kind of talk a little bit about all the different things that NASA does and is doing to protect our environment. And that's not just Earth system science, that's also aeronautics. How can we make air travel and human activity more environmentally friendly? So it's approximately a 2-minute, 45-second video, and it's a nice sort of way to kind of tie together all the different things that NASA does and is doing to try and help address how do we protect our planet. In addition, we have a couple of other resources for you educators and those of you who might be interested in Earth system science. We always update and have available a bunch of different multimedia for Earth Day, and we also have a bunch of different activities. Now, of course, the last 2 years, because of the pandemic, that has been virtual events. This year, we're going to have a live event over a couple of days, April 22nd through the 24th in Washington, D.C. It'll be at Union Station in Main Hall between 12 and 5 p.m. Eastern. But I know many of you are not in D.C., and so there is a virtual event. It is going to occur from 10 a.m. to 7 p.m. Eastern on April 22nd, Earth Day, in fact. And so if you'd like to register and attend the virtual event, the web address there is in the bottom right corner there for you. Okay. In addition, NASA usually creates a Earth Day poster every year. Now, Earth Day 2022 poster has not yet been released. However, we do have a website where you can go and you can download, and these are both like for wallpaper or screen backgrounds, stuff like that. You can download all of the Earth Day posters that have been released up to and including last year. And when Earth Day 2022 poster is released, it will be found at this website as well. And so I just want to make this aware so that if you'd like to incorporate this in your classroom, that you'll have this. And one of the things that was intriguing about last year's Earth Day poster, which focused really on honeybees and the colony collapse disorder that is threatening to disrupt this pollinator's life cycle and its incredible importance to agriculture all around the world, was a video that was basically a way for the artist who is in residence here at NASA. I believe she's at Goddard Space Flight Center. She basically talked a bit about how she came up with the idea and how she actually created the poster. So if you're interested in learning more about how the Earth Day 2021 poster was created, the one with the honeybees, I have the link for that particular video at the bottom. I won't actually play it at this point for time's sake. And that brings me to a very important piece that you can use from an instructional resource perspective. So a lot of times when we do these webinars, we focus on the science, we focus on the engineering, we focus on the math. And a lot of times, particularly for the elementary grades, it would be super helpful to be able to have a cross-disciplinary or an interdisciplinary sort of a curriculum. And so pointing out that NASA has artists on staff, graphic designers, people who are very much artistically inclined, allows me to, share with the fact that we need people who have that artistic talent to work for NASA. And so this allows for the ability to say, you know, we can incorporate arts into the STEM curriculum. We can have our students make their own Earth Day posters, and whether they use pictures of Earth taken from satellites of the International Space Station or from their imagination, as was the case with the Earth Day 2021 poster, this is a way to encourage arts, and sometimes I know in certain school districts, I know my school district, we were sometimes crunched for time for arts and music and things like that. And so this was a way to kind of help supplement art curriculum in our schools by incorporating that into our science classroom. So I just throw that as a suggestion. If you're looking to make your STEM curriculum a STEAM curriculum, there's some inspiration that we do hire artists. We do have them do a lot, pretty much any of the posters that you see, any of the videos that you see, those are all artists. So there is very much a definite place for people with artistic interests at NASA. All right, so talked a little bit about Earth Day, which is coming up. What I want to do is I want to make sort of a step back in time to last month, to a story that I know was all over the major news channels here in the United States. So I would venture a guess that it was on major news outlets all around the world. And that is the fact that an ice shelf collapsed in Antarctica. This was between the Glenser and Conger glaciers, and the frightening thing, I think is the best way to put this, the frightening thing about this was that the deterioration occurred rapidly within the span of about 2 weeks. I'm going to put on my arrow here, and you'll see on the left side, this is from NASA's Earth Observatory website. In the upper left is a picture that was taken by, I believe it was the Aqua and Terra satellites on February 22nd, and you will see that the ice shelf, which is where my arrow is, looks pretty robust. The Glenser and Conger glaciers are sort of towards the upper left corner here, but the ice shelf in that's of interest here is right here. It looks pretty robust. And over the span of about 2 weeks, there was a upper level atmospheric river that blew winds and weather patterns in such a way that the average temperature in Antarctica rose to about 40 degrees above Celsius. Yes, 40, not 4 degrees, but 40 degrees above zero. And with that kind of heat, which Antarctica does not see, you will see in a series of subsequent pictures here that were taken in early March. That's the upper right one. The one in the bottom left is about a day or two before the ice shelf formally collapsed, and then the one on the bottom right is about 6 days after, I believe it's about 6 days after the ice shelf collapsed. So you can see between February 22nd, which is the picture on the upper left, to March 21st, which is the picture in the bottom right, this fairly robust ice shelf just completely disintegrated. And this was a glacier, an ice shelf where the scientists thought this was a pretty stable situation. Yes, it was losing ice about this area of 1 square kilometer per day, but this extraordinary weather event that pushed the temperatures up so high really caused a catastrophic destruction and disintegration within a very short period of time. And so that's part of the impetus for talking about this evening. But this is not the only break or collapse that has happened within recent memory. Almost 2 years ago now, there was a piece of the Greenland glacier, this would be land ice, that broke away, a size piece of ice that was about twice the size of Manhattan, so that's about 113 square kilometers. That chunk broke away from Greenland's largest remaining ice shelf. So that's the Arctic. So I have sort of an example from the Antarctic, the South Pole, an example from the North Pole. So this is not isolated to one pole or the other on our planet. This is something that's happening at both poles. And so this is something that's of concern and scientists have been monitoring this for a while. In addition, last month, or actually this is now February, so this is now 2 months ago, there was an interagency report released by at least a dozen agencies here in the United States who all work together, basically reporting projections of the latest models based on satellite data and other scientifically collected data to kind of give us an idea of what to expect in terms of sea level rise based on what's happening with the climate. And so I give you the link if you're interested in the technical report. I think it's like over 100 pages, and there's lots of different models. And what they've basically done is they've taken the satellite data and using sophisticated computer modeling, they've come up with, I believe it's about 5 different scenarios based on how fast the atmosphere and the oceans are warming. So there's a little bit of uncertainty because of course it's the future, but based on what we've seen and what we're currently seeing, the scientists are able to give us a fairly decent idea of what might happen and give us several scenarios. So that's what the report does. It's focused primarily on the United States and coastal communities. And there's 4 basic takeaways from this report. The first one is that in the short term, the immediate future, the next 30 years, the average level of sea rise here in the United States is going to be somewhere between 0.25 and 0.3 meters. Now that might not sound a lot until we convert it over to the inches and miles. That's 10 to 12 inches, almost a foot. Now that is an average, meaning that regions in the United States are going to see differing amounts. Some of them are going to experience sea level rise, and what I'm going to show you in the next slide is some are actually going to experience a sea level drop. So, but depending, setting aside the regional differences, about 12 inches or 0.3 meters of sea level rise was what we can expect next 30 years, which is why some of that coastal tidal flooding is going to become more problematic. Storm surge, things from hurricanes, will also increase and reach further inland. So things where moderate flooding, and this is the type of flooding that can cause damage, may occur as much as 10 times as often as it does today by the year 2050. In taking a look at what other factors are contributing to this, emissions, human activity, what we're putting into the atmosphere and what we're putting into the oceans is driving this. And that's part of where the uncertainty is, because there is definitely talk about trying to reduce our emissions. And depending on how successful we are, and when I say we, that's all the countries around the world, depending on how successful we are in terms of mitigating or reducing the amount of emissions and stuff we put in the atmosphere and the oceans, will largely determine how bad the sea level rise may actually get. And the last thing is that the satellite data imagery is absolutely essential to understanding what's going to happen with the sea levels and how we can help the communities, particularly coastal ones, be able to adapt. So this is the slide that I was talking about. This is from NOAA, the National Oceanic and Atmospheric Administration here in the United States. So this, of course, is focusing on the United States to include Hawaii and Alaska. Now, if you take a look, and where is my arrow? Where's my arrow? Oops, come back here. So if you take a look along the east coast of the United States here. So I mentioned that here in Hampton, Virginia, we're experiencing issues with tidal flooding, nuisance flooding. You'll notice that a lot of the arrows here are in the upward direction. This is to indicate that we're going to see sea level rise. Those levels are going to rise here on the East Coast. If you take a look along the Gulf of Mexico, so this includes Texas, Louisiana, Alabama, and the western side of the Florida Panhandle, not only are the arrows rising, but you'll see that some of them are even red. So red means the most extensive sea level rise, as opposed to the green and yellows that you see along the East Coast. I want to draw your attention to the southern reaches of Alaska, where you'll see that the arrows are actually down. they're going in the downward direction. Alaska is probably going to see a reduction in sea level rise. And there's a number of different factors that are responsible for this, but the biggest thing that appears to be explaining the difference between, say, the Gulf of Mexico and Alaska is in the Gulf of Mexico, there is a lot of fossil fuel and water extraction from underground. And when you pull those things out from under the ground sinks. I did a webinar about a year ago about the Mississippi Delta and how there's issues with deposits of sediment. One side of the Mississippi Delta is growing, it's getting a lot of sediment, but the other side is sinking, and part of that is because of things that are being extracted from the ground. Whereas in Alaska, it's not so much the extraction, but it's the plate tectonics, the plates that are pushing up against each other, causing the elevation to rise. Alaska, particularly along the southern edge, is along the Ring of Fire, and so there's a lot of seismic activity and plate tectonic movements, and so the reason that you're going to potentially see a sea level drop along Alaska is the fact that plate tectonics pushing the landmass of Alaska up relative to other places where we're going to actually see a sea level rise because the land is dropping. So I want to give you some tools that you can use in your classroom to track, and as I mentioned in the report, you're able to basically track pretty much all coastal communities in the United States, and in some cases with these tools, all around the world. But as I said at the beginning of this program, I'm going to focus mostly on the ones for the United States because primarily our teachers are located here in the United States. So the first one that I want to point out is actually attached or sort of a visualization tool for that interagency report that I just showed you some takeaways and a visual from. So the first website will actually take you to this interactive tool, and I've just put my little arrow here right next to it. And what it is it's a drop-down menu, which is over here on the left. And what you can do, there's two choices here. You can choose how far in the future you want to go, and then there's also a way for you to pick the different scenarios. Remember, I said the different scenarios are determined by how fast the atmosphere and the water may increase in temperature over the next 100 years or so, and I mentioned that is a variable we're not entirely sure of, because if we're able to reduce what we're putting into the atmosphere, that will help to slow down the warming and will slow down the sea level rise. If we're not as successful in reducing what we put into the atmosphere and the ocean, the temperatures will rise quicker and the sea level will rise quicker. So there's several different choices that you can pick to see what exactly is going to happen to your particular community. Down here in the lower right is a scale that will show you the degree. So the browner the color, the more extreme the sea level is going to rise. And the final thing to point out with this is that there's a couple of little blue dots. If you click on the blue dots, it will zoom in. There are some tidal gauges and places where we're able to actually measure along the coastline what the sea level is. And we have incorporated those tidal gauge measurements or locations into this tool. So you can zoom in. There may not necessarily be a tidal gauge or a data station close to where you are teaching or where you are, but there might be one within a certain distance that you can zoom in and you can show your students, here is a station, here's the data, etc. So you can do that all along the east coast of the United States, the Gulf of Mexico, and then of course along the Pacific coast. The other thing that I want to point out is another federal government resource here in the United States. It's called the U.S. Climate Resilience Toolkit. It's a place where one can access information and tools from across the government to understand what's going to happen to sea level rise, but also tools to help manage this. So this particular toolkit is for a variety of audiences. The reason I pointed out for teachers is I know that there are occasionally problem-based learning scenarios where you may want to have your students be like a mock UN panel, and how are we going to address sea level rise, and what sort of tools might we want to use to help coastal communities mitigate or manage this kind of tidal flooding. And so these types of resources that communities are actually using may be helpful to help students understand what sorts of strategies are being used to try and address sea level rise, and what sort of information is available. And so that can be used as part of a problem-based learning curriculum if you are doing that in your classroom. In my classroom back in Northern Virginia, we were actually on the Potomac River. Like literally the school was less than a quarter mile from the Potomac River. In fact, our marine biology class, which was a senior elective, they would just walk down during the 50-minute period to do their marine biology lab and then come back. And so this was something that was of great interest. We would be focused on the marine life. So, you know, clams were a very big part of the economy of my community. And so monitoring the health of the clams and the fish that were in the river and stuff like that was something that we would basically take a look at. And so it wasn't necessarily a cookbook curriculum. It was something that was very much of interest to the students because their parents were in the fishing industry or in the clamming industry, or they had restaurants that were dependent on that and stuff like that. And so I know, having conversations with teachers who are in coastal communities, this is something that they're dealing with right now. We are dealing with it here in Virginia and stuff like that. And so this is something that has come into the curriculum, is how might we design solutions to this, and the students get to do real world science and develop real world solutions. And that, of course, usually is much more effective than just teaching out of a textbook and stuff like that. So the toolkit may be something that could be useful if you are interested or are actually doing a problem-based learning type of a unit, whether it be a mock UN or tackling some kind of situation that's affecting your community. How much you advise your local leaders as to what they might do in terms of responding to sea level rise in your community. NASA, of course, has a variety of tools that you can use. The portal is probably your best place to get started, and the website there is there. It allows you to access data sets. It has a running dashboard that kind of gives you sort of like a ticker, sort of like the New York Stock Exchange, gives you updates on what's happening to the prices of stocks. This ticker kind of gives you an idea of what's happening to ice sheets around the world, and what's happening to ocean temperatures and things like that. So this is a great place to go to get more information about the data sets, which I'll show you how those are collected in just a moment, and certainly what visualization tools are available as well. So there's an interagency report toolkit, and then NASA has one that's a bit more in-depth. This is been updated occasionally. This is also was done in combination with the United Nations and the IPCC report that came out, I think it was about 5 or 6 years ago. And so this is a bit more detailed, but it's the same idea. You can track what's going to happen with sea level rise. In this case, all around the world, because of course our satellites are obtaining data from all over the planet. And so once again, there's these drop-down menus where you can determine how far out, what kind of model that you want to apply. And once again, the blue dots are specific ground stations, tidal gauges, if you will, where you can zoom in and get more details as to what exactly the model is saying is going to happen at this particular location in the world. So I know we have some people on the line from India. I know we have some people from Thailand. We have some folks from the United Kingdom with us this evening. So this one, particularly if you're an international educator, you may find more useful because it actually covers not just the continental United States. Okay, and Guatemala, let me just kind of, the way I took the screenshot, but yes, you'd be able to check out Guatemala on this as well. Central and South America. Okay. And that's kind of the fun thing about having folks from all over the world is being able to compare and share and contrast what's happening in your corner of the world with what might be going on with another educator in a different part of the world. Okay, so you're very welcome. Yeah, very welcome, Magdalena. Okay, so just kind of a quick review. I know I've only got about 9 minutes, so we need to come back to the demonstration here. I've just put in a couple of slides just to kind of the basic science. So earth science, we talk a lot about the carbon cycle, we talk about the water cycle, and stuff like that. So this is a way to kind of tie in, particularly for the United States teachers, whether it's next generation science standards or your state standards, where you have to cover those particular topics. This is where you might be able to bring in these sorts of conversations in terms of specific content that you have to cover. And when we talk about sea level rise, there's a number of factors. There's a reason why there's 5 different models in the latest report that was released. And so kind of talking about how do we determine what's going to happen with a particular community and its sea level rise. Here are some of the factors that go into that model. So a model is not just the result of one variable, it's a result of many variables, and we let the computers figure out and crunch the numbers to come up with various outcomes. And so in this case, the green on the left is not a good thing. These are the things that accelerate sea level rise. So things like surface runoff or melting of the ice caps or thermal expansion of the water because it's getting warmer, or as I mentioned, particularly for some place like the Gulf of Mexico, taking things out of the ground and the ground sinking as a result. These are the types of things that are going to cause the sea level to rise at a faster rate, as opposed to the red, which in this case is actually a good thing. Red is going to be things that slow down or possibly even reverse sea level rise. So if we're able to store groundwater or freeze water and trap it in the polar ice caps, or as was interestingly pointed out in a study taking a look at data from the 1970s, the sheer amount of construction of dams across rivers all over the world actually helped to slow down or actually negate sea level rise during the 1970s. So the interesting thing is there's a lot of discussion in communities because the dams interfere with natural cycles like in the North Pacific Northwest here, salmon running up the river to spawn. That has been disrupted to some extent because of the dams. So there's a lot of discussion of breaching the dams and just deconstructing the dams. That's good for one thing in terms of restoring the natural biological cycle in that particular area, but what happens to the sea level rise? Because as I said, in the 1970s, the sheer amount of construction of dams actually slowed down or eliminated sea level rise for a short period of time. And as I pointed out with Alaska, plate tectonics pushing up the ground. I mentioned a little bit about tidal gauges. I won't spend too much time on this slide, but if you're interested in understanding how these work and are not already familiar, this slide will be in the slide deck that you get either as a PDF version or as a PowerPoint. There's a couple of different ways that NASA collects information beyond the tidal gauge record. We have 2 projects that utilize scientific aircraft and collect data that way. Operation Icebridge is run out of Wallops Flight Facility, which is located here on the eastern shore of Virginia. This actually alternates between surveying the ice cover in the Arctic and during one part of the year, and then it goes and it surveys what's happening to the polar ice sheets in the Antarctic during the other part of the year. So we take information collected from aircraft and use that to calibrate that, or compare it, I should say. It's probably more better to say it, to compare it with the satellite data imagery. And I'm seeing a question, so do you know if they use drones for Icebridge? At this point, I am not aware that they are using drones, just simply because of the sheer distances that have to be covered. However, I won't necessarily say that they're not used at all in terms of surveying ice. They may be useful for sort of shorter distances, but in terms of the amount of distance that Icebridge wants to cover in terms of trying to get a comprehensive survey of the ice cover, it's probably not something that's used as a regular course of operations. That might be used as a supplemental, though. If you have your hand raised, go ahead and drop your question in the chat box, and that way then I can try to address it as I go along here. One other project that has used airplanes and scientific data collection using aircraft is abbreviated OMG, that actually stands for Oceans Melting Greenland here at NASA. And this has been attempting to understand how the oceans, the water, and the interaction with the ice at the land's edge, the interactions between what's happening with the water and as it interacts with the ice, that may hinder or accelerate melting of those ice regions. And so OMG, Oceans Melting Greenland, I think it's just finished its 6th year of surveying up in, I believe it's Greenland. Yes, Greenland. And so if you're interested in learning more about the program, I do have a link for a video. It's about 5 minutes long. It'll give you an overview of what the mission is hoping to accomplish. Okay. Satellites are a big part of where we get our data from. And so Alyssa's saying, I'm FAA certified drone pilot, so I could try to come up with something. Yes, yeah. And even if it's not ice cover, surveying the ice, or excuse me, surveying the coastline. I know out in Wallops Flight Facility, the issue of sea level rise is rather dire. And so I know that there has been some use of drones to survey what's happening with the coastlines as interaction of erosion with the sea levels rising and stuff like that. So yes, you're absolutely correct. You probably could develop something that you could use the drones and also incorporate this information from sea level rise. And just because I don't have it here does not mean that we're not using drones in that way. I just haven't necessarily seen any discussion about it in the channels that I normally check. But I can check, and if I find something, I can put that in the resource email, and that way then you can have something to follow up on. So our Earth observing system has been around, as I said, almost from the moment that we were created as NASA in the late 50s. And that was one of our charges, to keep track of Earth and take its vital signs through these satellites. And so the red arrows are the particular satellites that I'm highlighting here in this particular webinar in terms of sea level rise. There are some other satellites in this graphic that are capable of taking measurements and contributing to the data sets in terms of what's happening to sea level rise. Things I'm particularly thinking of are like Terra and Aqua, which were the satellites that provided that imagery of the ice shelf collapse. So just because the 4 red arrows are just pointing to 4 satellites does not mean that those are the only Earth observing system satellites that are involved in this conversation and are contributing data to the modeling of sea level rise. ICESat and ICESat-2, which stand for Ice Cloud and Land Elevation Satellites 1 and 2, have been up for a while. They have a single instrument on board, and their primary mission, as kind of indicated by their name, is to keep an eye on Earth's cryosphere, which is the ice sheets and the sea ice, and basically map and keep track what's happening to the land ice, which is partially the ice sheets, and then the sea ice or the icebergs. So ICESat-2 primarily interested in keeping track of what's happening to our ice cover, our cryosphere. GRACE and GRACEFO, which is Gravity Recovery Climate Experiment Follow-On, is a unique setup. This is a system that's managed by JPL, and I realize that it is 8 o'clock. I'm almost done, and I know I still have to show you what's happened with my demonstration here. So GRACE and GRACEFO are 2 satellites. They're separated by a distance, and they're communicating with each other. And the reason they're communicating with each other is they're capturing data on what happens to Earth's gravitational field. This is done through what's called an accelerometer. And when there's slight changes in the gravitational field, when the depth and where water is located on the planet changes. And so while it may not sound very intuitive initially, it's something that provides an additional way of getting at this idea of where is the water distributed on our planet and how is it changing. So something like, okay, the water was originally trapped in an ice sheet, but now it's part of the ocean. That's going to make slight changes in our planet's gravitational field, and GRACE and GRACEFO are sensitive enough that they're able to catch that. And so over the course of several years, there's now this repository of measurements that can now be used in computer modeling to see where is water shifting. And so it also points out things of places where starting to experience greater and greater water stress or water scarcity. Certainly there's places on our planet that have already always had issues with water stress and water scarcity, but as the climate changes, where the water is found is going to change, and as it is found in different places on our planet as a result of climate change, that's going to affect the gravity, and GRACEFO can pick up on that. So in terms of monitoring specifically sea level, this is something that in the grand scheme of things is only about 30 years old. The tidal gauges have been around for over a century, but they're kind of haphazard. Not every place on the planet has a tidal gauge, and certainly not all of them have a continuous record. But if you want to go back and understand what happened to our planet's oceans beyond 30 years, the tidal gauges are pretty much it. So it's only within the last 30 years that we've really had satellites dedicated to monitoring the ocean's sea level, the planet's sea levels. This started out with a series of European Space Agency satellites. TOPEX and Poseidon was the very first one, was launched back in 1992. There's now been a series of satellites, Jason 1, 2, and 3, that have kind of carried on. So there's kind of a sort of subset system whose job it is to entirely monitor sea level. And there's a number of different instruments. Altimeters particularly are important in terms of measuring the height of the oceans. And so that's sort of the background for the latest satellite, which given the time, I'm not going to necessarily show the video right this second. I might circle back around and show it after I've formally finished so you can see it. But I do have a video that kind of gives you an overview of Sentinel-6. Michael Freilich is the name of the satellite, and it is another in this series that's designed to measure sea level height from space. So a little bit about Sentinel-6. As mentioned, it's part of this it's now sort of like the next chapter in this 30-year partnership between the United States and Europe in producing these satellites that are specifically designed to measure the heights of oceans. It's named for the former director of NASA's Earth Science Division, Michael Freilich, and it was launched back in November of 2020 from Vandenberg Air Force Base, which is typically where we launch satellites if we want them sort of going in a polar orbit, go over each of the poles as it orbits the Earth. And so it is actually one of a pair, or it will have a twin satellite, which will be, right now it's referred to as Sentinel-6B. It may get a formal name by the time we launch it in 2025. But right now Sentinel-6 is by itself, but its twin will be joining it in a couple of years. And as a partnership, it's several instruments provided by NASA JPL, Jet Propulsion Laboratory, and mission operations are shared between NASA and NOAA, and then ESA and EUMETSAT in terms of monitoring it. The interesting thing about Sentinel-6 is because it has the latest technology, it has now become the standard by which we compare all of that other sea level, that repository of sea level data that we have from the 30 years of satellite data. We're able to now compare that to the most sophisticated state-of-the-art equipment that's on Sentinel-6, and we now compare it. So Sentinel-6 is now kind of like the gold standard because it has that technology. It's been validated before it came online, so we're certain that the data that it's collecting is trustworthy, but we're now able to use that and compare that and see how well the previous data matches up with what this satellite is sending us. So Sentinel-6, as I said, will have a partner here shortly. So with that, that brings me to the end of my material. Let me go ahead and minimize my slide and we can collect our data. And I will bring my slides back so that you can get my email address, because I know several of you need that in order to give me a heads up here. So let me bring my camera back. Okay. And let me go ahead. And of course, it's been relatively warm here in Virginia the last couple of days. So my ice cube that I showed you at the beginning as sort of my standard, here's what the ice cube looked like, is completely melted. And I can tell you that the ice is almost completely melted in both. So the ice cubes were about this long when I started. They're about this long now as we're finished. And in my purple, which is my land ice, I still got, they're a little bit bigger, but in here, in the sea ice, the ice cubes are, well, there were 3, there's now only 2. The third one's completely melted. So where's my ruler? Okay. All right, so most of you opted for sea level rise. So we'll go ahead and we'll measure the sea level one first. I'm just going to rotate it around here. Let me see. It's going to jostle a little, but I can actually see there's about this much more above that painter's tape reference that I started with at the beginning. Okay, so let me go ahead and start here. All right, so it looks like my sea ice is at about 1.4. It's actually in between the 1.3 and the 1.4 mark. So we'll call it 1.4 just for the sake of rounding up. Okay, so final sea ice level, and I'll put in this orange, equals 1.3, what did I say? No, 1.4 centimeters. Okay, so I'll put that in the chat box. Make sure I spelled that right. Sea ice level orange 1.4. Okay, I'll try to kind of bring it, but just in terms of the sloshing, you may not necessarily be able to see it real well. But there is a little bit of space between the top of the painter's tape. Let me bring it up here. The painter's tape and the actual water. But because I'm holding it and I'm not on a level surface, it may be really hard for you to be able to see that. Okay, so that is our sea level. All right, and let's go ahead and take a look. Same thing. I got a substantial, just from looking at it, it looks like it's more. Yeah, it's more. There's a bit more space between the top of my painter's tape and the water. I'll try to rotate it once again, camera and the fuzziness. You may not necessarily be able to see it. Let me see if I can bring it up a little bit. You might be able to see it a little bit, but there's a little bit of distance, and it actually looks like it's more distance than what's in the sea ice. So let me go ahead and bring this over to the side so I can measure this. And let's see. I'm seeing about 1.5. Let's make sure I measure that right. Yeah, it's about 1.5. Okay, so let's see. So make sure my cursor is in there. So final. Oops. I got a B in there somewhere, not finball. Final. Final. That was the land ice level. That was the purple. Equals 1.5 centimeters. So this is only one iteration. So once again, coming back to the nature of science and doing an experiment, you would want to have possibly several student groups doing this so that you'd have a more reliable data source. But just from what I'm seeing here visually and then with the measurements, it actually looks like the land ice won out as opposed to the sea level. So it is 8:10. Let me go ahead and flip forward to my last slide. And while you're writing down the, where's my lids? There's a feline education specialist who wants to do a quality control check. Hi, Miss Ninja. Where's my lid? I better protect you from yourself. All right. Going to go ahead and put the lids on my canisters. All right, so Miss Ninja may come a little bit closer. She is incredibly interested. I will tell you, she was incredibly interested before. She was trying to stick her head in the glasses that I had the ice staged in and the water. Oh yes, very, very curious. Yes. So she's going to check out, and Mom has taken away all the fun by putting the lids on the top of my ice canisters. But as we finish up here, there is my email address. So if you need to send me an email about certificates, there it is. If you have any follow-up questions, which I will circle back around and see if there's any questions, I will do that. But to kind of bring the sea level and the land, the sea level, the ice, the sea ice versus the land ice, what should happen when you do this demonstration is what actually happened here. If you think about a glass of water, okay, and this is separate, I can use this one because it's thin, it's narrow enough Miss Ninja can't stick her head down it. If I were to put an ice cube in here, the water tends to rise a little bit, as opposed to if I have the ice cube at the bottom and I pour the water in, the water is not necessarily going to rise that much. So what ends up happening is if you put an iceberg, sea ice, sitting in the ocean, it's already displaced. Yep, she left. Mom put the lids on, so no fun. We're going to leave. So if you have an iceberg in the sea already, you've already displaced the water. You've already displaced that volume. So even if the iceberg melts, the water's already been displaced. However, if the glacier, the land ice, is sitting on the land, it's not in the water. The water hasn't been displaced yet by whatever volume is in that glacier. So in the case of, for example, like the ice shelf or the Greenland glacier, where that ice is not in the ocean yet, that water, when it's added, will cause the level to rise. Whereas an iceberg that's already sitting in the ocean has already displaced. And you can do this with a simple. I mean, even when I was a kid in summer, my sisters and I would try to pour the lemonade to like the very edge, and then we'd be like, oh, we forgot to put the ice cubes in, and then we drop the ice cubes in, and boom, it would spill. Whereas if we had remembered to put the ice cubes in the glass first, we wouldn't have had that problem because we would have already had the volume displaced because the ice cube was already in there. So what should happen with this demonstration, and it doesn't always happen, but what should happen with this demonstration when you do it with your students is that the land ice canister should have more water rise because those ice cubes are sitting on top of the Play-Doh. They're not already in the water. And so they're not able to displace the water until they melt and run off the Play-Doh and into the water. So just hopefully that makes sense. But certainly I'll stick around and answer any questions you might have. So just a reminder, the post-event quality surveys will go out in the next 24 hours. Unless you email me and say, I need it sooner than that, I will usually send out the certificates of attendance a week after, which for us will be, that should have been changed. That should have been April 21st, not March 31st. So I apologize. So the surveys will go out sometime tomorrow, which is April 15th, and then the certificate of attendance for most of you will go out April 21st. I'm sorry, I did not catch that in my proofreading before I uploaded the slides, so I apologize for that. Okay, if you want the recording link and the additional resources, send me an email or drop a link or drop a notation in the chat box that you want the resources with your email. And yes, that is my email, ann.e.weiss@nasa.gov. That is my email address. And then over the next 2 weeks, we will have a variety of webinars. So the list that you see towards the bottom of your screen is by no means an exhaustive list, but these are the ones that are tying in with Explore Earth, which I said is our main focus this month because of Earth Day. So if you're interested in any of those, you can go ahead and check out those. If you're interested in learning more about sea ice, Dr. Garcia from Kennedy will be doing one Tuesday, April 26th at 6 p.m. where he'll talk a little bit more about sea ice. So if you're interested in learning more, that might be something to follow up with. But certainly, any of the webinars that my colleagues do are always informative, and we're all fun. So not all of us have feline education specialists. Some of us have canine education specialists, but certainly any of these are good. But the full list is usually in NASA Express, so you can always check out what else is left. You'll notice that my next webinar, which is on April 28th, I'm going to be taking a look at microplastic pollution and how we track that. That is a participant request, so plug if you're always interested in seeing something, seeing me cover something. You can always send me an email and say, hey, I'd really like it if you did a webinar on X. I can then do that, and Miss Ninja is going to try again and see if she can get into the buckets. But you'll notice that the address for this one is a little bit weird. We had a slight hiccup with our system last night that I discovered. So this link is a little bit longer than the others, but it will take you to the registration for my next webinar, which is 2 weeks from tonight. So with that, I thank you very much for your patience and going over a little bit, but it is a fascinating topic, and I hope that you've learned something that you can take into your classroom or share with your communities and stuff like that. What was your email again? The slide is shown. I'll go ahead and drop it in the chat box. Give me a second to type it. It's ann.e.weiss@nasa.gov. Okay, so there you go. And yes, certainly for those of you who observe Good Friday and Easter, happy Easter to you. I think the Orthodox Easter is next week. So if you are Orthodox observing, happy Easter to you, and stuff like that. But I will stick around and circle back around for any questions that I may have missed throughout the program. But thank you again for your time, and be safe and have a wonderful day wherever you are. Okay? You're very welcome, everyone. You're very welcome. I'm going to circle back around and just see if there were any questions I might have missed. Now it's possible she's kind of given up on the canisters, and she's drinking because there's a little water bowl here for her. It is getting to be dinner time, so she might be trying to promote dinner as well. Remote sensing, yep. And I did even include remote sensing. I had so much other stuff that I wasn't able to kind of directly address remote sensing, but yeah, that's an important point to hit home, Adrian, that you're looking to find ways to teach remote sensing. This is a great, let's see, so Neville's saying you hear there are 4X rocket launch sites being developed in Scottish Isles. Simply, they can launch SSO polar orbit satellites. Yep. Yep, I think I was noticing, I'm not sure if it was Wales or if it was Scotland, but there was an environmental issue that they wanted to do that for not only the SSO and the polar orbit satellites, but also sort of space tourism, and the local community was not necessarily as weren't buying in as much because there was something unique. It might have been the bogs or something about the local environment that they were worried that the construction of these spaceports were going to irreparably harm these fragile ecosystems. So that's also a very interesting thing. I know we have that issue in Texas with SpaceX, and I think it's Arizona with Blue Origin, is the building of these spaceports and how is that impacting the environment. Of course, it being Earth Day, it's a great topic to come back. How long do we have until we're done to attend a group meeting? Izar, I think you probably have left, but normally we're about an hour long, so I typically should be done or should have been done by 8 o'clock. But as always, I usually have a little bit of extra interest or information, and so I usually run over, but our webinars are usually an hour long. At least that's what they're supposed to be. Okay. Okay. Very welcome. Okay. Very welcome. Okay. Very, very welcome. I'm glad Glad you hopefully have found something useful from the webinar. Yeah, okay. You're very welcome. Okay. It's email, I put it in the chat. You're very welcome. Adrian, you're asking, Play-Doh land, does that happen? And it is possible. Hopefully by having the same amount of water in each. You want to go up there? Go up there. You want to go up there? Go up there. Okay. I'm just going to have to move the box so I can actually read what my participants are telling me, young lady. So having the Play-Doh absorb is very possible. But that's one of the reasons why usually we take and let the samples have the same amount of water and the Play-Doh sit in it. That way you are hopefully standardizing it or controlling that particular variable. But I noticed that when I went to go set this up, my Play-Doh was a little dried out. So it is very possible that the Play-Doh could have absorbed some of the water during the demonstration and may have done it unevenly between the two. It seemed as though both of the Play-Dohs were about the same level of dryness, but you're absolutely right. There's additional variables, and this is why, again, this is a great activity, not just for sea level rise and earth science, but also for the nature of science and controlling variables. And if for some reason, because I've told you here that what should happen is that the land ice bucket should have slightly more or slightly higher level of water by the time you get done with the demonstration than the sea level. But let's say for sake of argument, you did this with your students knowing that you were supposed to hopefully see the land ice depth be greater, and you had a number of students where their sea ice, their level was actually the higher of the two. So you could have that discussion with your students saying, okay, some had the land ice have the higher level, some had the sea level, or the sea ice had the higher level. So you could have that discussion about, okay, why might we have gotten different results if we set up the experiment the exact same way? And that might be, one variable is that the Play-Doh actually absorbed the water. Another thing that you could bring up is, having that difference, how does NASA scientists or ESA scientists or just professional scientists, the ones who are actually doing the computer modeling and telling us these things in these reports, at what level do they have some level of certainty saying, okay, we have all of this data, we might have some really weird data points or outliers. At what point do we become confident that what we're seeing is a trend and not some aberration of the data? So there's also that conversation that you could have in terms of, what sorts of things do we have to be certain that what we're observing in our data from the satellites or for the airplanes or wherever we're getting the data from, at what point do we become certain that what we're measuring is actually real and not some artifact or something weird, that what the data is telling us is something we need to be paying attention to? So there's a lot of different ways that you could take this that address very important issues of doing science and nature of science, and some of the criticisms that have been raised in response to climate science research. Well, you're doing all of this modeling. This is stuff that's going to happen in the future. How can you be certain that what the computer models are telling us is actually what's going to happen? So these are great discussions to have with our students. Yep, she's don't let that cat near the Easter Bunny. Oh, nope, 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 no Easter Bunny, no Easter Bunny for her. Her name is Miss Ninja, and she is 17 years old, almost 17 and a half year old tabby, calico tabby. She, for those of you who are new or have not been with me previously, she shows up for all of the webinars at some point or another. So she has a little bit of a fan club, but she has, you see the spiky fur down towards the bottom here. She has just kind of sat down, and this is what she will do. She'll just sit and just hang out while I'm doing my webinars. So So, but yeah, her philosophy is strangers, that's you all, are friends she hasn't met. So she hears me talking, she assumes I'm talking to somebody, even though she can't see you, and so she wants to get close to the computer so she can say hello to you. So that's why. So Ari, you're saying, so with the available data from satellite, NASA must know where around the world the water will be dramatically rising in the near future. And once again, coming to what I just kind of talked about in answer to Adrian's question, with some degree of certainty, yes. Depending on that 30-year record and taking a look at what's happening. And of course, it's not just the sea level data that we have. The satellites are providing data on what's happening to the temperature of the oceans, what's happening to the temperatures of the atmosphere, what's happening to salt concentration in the oceans, et cetera, et cetera. So it's not just sea level rise that the scientists are comparing these modeling results to. It's part of a larger sort of a framework, and we're just focusing on the sea level piece of it with this particular webinar. But with modeling, there's always a degree of uncertainty, and so that's why if you take a look at that U.S. interagency report or even the UN reports, there's usually several different scenarios that they play out, because even though we might have certain level of certainty in certain variables, there's some degree, sometimes a high degree of uncertainty in other variables that are part of the model. And so within a certain degree of confidence, yes, we have some idea that, for example, the eastern coast of the United States or even the Gulf of Mexico, that there's going to be a substantial amount of sea level rise, because in those cases, at least particularly with the Gulf of Mexico, we know what's being pulled out of the ground, and we have some idea of the rate at which it's being pulled out of the ground. That's the fossil fuels in the groundwater. So that's not necessarily dependent on something like, okay, what's going to happen with emissions into the atmosphere and how is that going to affect the temperature? That's going to be a far more uncertain variable in the model, because we still have an opportunity to change our behavior and change the emissions of what we're putting into the atmosphere, as opposed to people have to drink water. We need to pull the groundwater out of the ground in order to be able to drink it. So there's, certainly with a fossil fuel extraction, okay, the argument could be made that might slow down if there's not as much of a demand. But that's now where we bring in the geopolitical situation and the fact that because of what's going on with Ukraine, we've now have economies that are fossil fuel dependent and need fossil fuels, and we're not getting them from Russia. We need to get them somewhere else. So are we going to be pulling fossil fuels out of the ground faster in certain places than we were before to compensate for the geopolitical situation that's affected the rate of consumption and the sources of fossil fuels around the world? So the short answer is yes, there's a fair degree of confidence that it will be dramatically rising, but there's still uncertainty and there's still room for humans to change their behavior and mitigate how severe it might be in the future. Lots of teachable, yes, yes, yes. Yeah, great philosophy, yep. Yeah, yeah, Magdalena, yeah. And as I said, that's, I shared with you an example of what happened with summers. We'd have, we want to get a glass of water, we want to get a lemonade, and, we were so thirsty we'd fill up the glass and then, oops, forgot the ice cubes, and we'd pluck it in, and then boom, we had water or lemonade everywhere and stuff like that. So that type of a demonstration that you're talking about, Magdalena, is great, because chances are your students have observed that at mealtime, whether that be in the lunchroom or at home or with their friends or something like that, that they've seen that. I know my sisters and I, we would have a competition of like how high could we, or how much could we fill the glass, and then put the ice cube in and it not run over and stuff like that. So yeah, that anytime you can use something that kids have some personal experience with, just either accidental or on purpose, as it was the case with my sisters and I, it's great to be able to incorporate that into your teaching. Very welcome. I'm going to go ahead and stop the recording so that it can start buffering. in preparation for the resource email. So thank you for your your questions and your attendance, and